In this first video, I'm going to assume that you've collected your raw data. I'm going to assume that you have installed Logger Pro on your computer so that you can create the graph, and that you have your data kind of collated in a sheet that looks a little bit like the one that you can see now. Okay, so the first thing we're going to do is just neaten up this formatting and make sure that we have space for all the things that we want to enter. So I'm going to add another column here, insert one to the left. And this is going to be called uncertainty and length. Okay, and of course we have our length on the leftmost column because that was our independent variable. We increased the length of the pendulum and then we measured the time it took for 10 swings to complete so that we could find the relationship between those two. Okay, so now I'm going to just fix the decimal places on this. So maybe increase it, maybe not 2, 1 should be sufficient. Oh no, actually I do want 2 because I did measure it to the nearest centimeter. And the uncertainty should be, well, technically I was measuring it with a meter ruler that had millimeter marks, so it should be a millimeter, in other words half a millimeter at each end. However, I don't know with that level of accuracy exactly where the pivot was or exactly where the center of mass of the pendulum was, so I'm going to make it a centimeter, just to be on the safe side and make sure that all of my values fall within my uncertainty. Okay, and then just to neaten these up a bit, I'm going to merge them and center them horizontally and vertically. I'll do the same with this one. Merge, center, and center. And that one is a bit long for that cell, so I'm going to wrap it as well so that it all fits. Okay, and here I have then my raw time data. So I'm going to highlight these 5 because I'm also going to add an uncertainty column here, and I'm going to merge those, and then I'll center this, and that way I have what all of these refer to in the top here. And then I've got my raw data there, and I want my average here, so I'll write equals average, whoops, open bracket, and then highlight the 3 that I would like to average, close bracket, and then enter. And then I'll grab this little bottom corner of the cell and drag down, and that auto-completes and averages each row. You'll see that we have a crazy number of significant figures here. We need to fix that. We only measured to the nearest hundredth of a second, so these cannot be more accurate than that. So we need to reduce the number of significant figures until we get to 2. There we go. Note that when we do that on Google Sheets, all of the data is still there, so if we use this again, it's going to use an unrounded number. It's just going to display the rounded number. Okay, finally, just to make this really neat, I'm going to anticipate a bit because I know I've got 2 more columns. I'm going to center everything so that all of my data is nice and centered. Okay, so now we want the uncertainty in the period as well. Uncertainty in 10t. It's not the period, it's 10t. And that ended up being a little bit too long. I'm just going to do that. And that is going to be equal to half of the range of the 3 values that I collected. So I'm going to choose the max one by that. So this max from C3 to E3 will choose just the biggest of those 3 values. And then I want to subtract from that the smallest of those 3 values. And then put all of that in brackets. And then I'm going to divide by 2. And that will give me half the range in these 3 values, which is my kind of rough estimate of how big the uncertainty is. And then I will auto-complete that for all the rows so that I have an estimate of the uncertainty and the timing for all of them. And the uncertainty and timing should always be just to 1 significant figure. We can see that these ones all will therefore be 1 decimal place, which means that we should be reducing these other ones. Although because this is not our final value, I'm going to just leave it to 2 decimal places for now, because we've got one last little thing to do here. So these last 2 are going to be my period, because I'm not interested in 10 periods. I want to find the relationship between the actual period and the length. So the period is going to have an average value and it's going to have an uncertainty. and the average value is going to be equal to this divided by 10, because I timed 10 swings and I divided by 10, and I'm going to just autocomplete that as well and just double check, is this a tenth of that? Yes, yes, yes. So that's good. And then I'm going to reduce that to just, in fact, I don't really know how much I need to reduce it yet. I'm going to then take the uncertainty and divide by 10, because the uncertainty will also be reduced by a factor of 10 when I divide to a single period. Okay, so now we can see that some of these are, well, they're all more than one significant figure, so we need to just reduce it. Let's just check. Yeah, they're all going to be reduced to 2 decimal places like that, which means that I need to reduce these to the same number of decimal places as the uncertainty. So now I have the correct values here. In fact, all of these values are now good. I'll add some borders and maybe either bold or do inverse coloring on this one, just to show that they're the headings. Okay, and then this is now my raw data table. I could copy this into my report. However, I'm going to just show you how to create your raw data graph using this stuff. I'll do that in the next video.